Here is a nice quadratic equations. Can you solve a and b when 4 to the power of a times 3 to the power of b, which is equal to 48, and 4 to the power of b times 3 to the power of a, which is equal to 36. The way to solve this is using a different method, like we can call equation 1 and 2. We can divide equation 1 into 2, or multiply, subtract, or add, and try to come up with a simplified form of a and b. Here let's first divide equation 1 into equation 2. Here we see 4 to the power of a times 3 to the power of b divided by 4 to the power of b times 3 to the power of a is equal to 48 divided by 36. We can see some simplicity that we can simplify 48 into 36, and we come up with 4 over 3. So that 4 over 3, we'll see some similarity: 4, 3, 3, and 4, which means we can simplify the equations into 4 over 3, in the bracket the power of a. That 4 over 3, we've got the same power by the principle of the power similarity. We can put it that way, and then we can say 4, that's 3 over 4, the power of b. We can put minus b, which is 4 over 3, the power of minus b. So we can come up with the same 4 over 3, 4 over 3 here, 4 over 3 here. So if we say let 4 over 3 is equal to u, and substitute this into the equations, we get u to the power of a times u to the power of minus b is equal to u. Here, multiplication, we can add these two, which means we can subtract a into b. Here we have u to the power of 1. We can say that a u to the power of a minus b is equal to u to the power of 1. Because the bases are the same, we can say that the powers are the same. So we can equate a minus b is equal to 1. If we call this equation 3, because we've got 1 and 2 equations on top in the beginning, and let's multiply this equation 1 and 2, and if we multiply 4 to the power of a times 3 to the power of b into 4 to the power of b times 3 to the power of a, and then we multiply 48 times 36. So our intention is to come up with a simplified form of these three numbers. Here we see 4 and 3. We can multiply this to get 12, so we need to find a way to get 12s in this side of the equations. So we have 4 to the power of a plus b, because 4 to the power of a is here, 3 to the power of a is here, 4 to the power of b is here, so a plus b in one side, and then 3 to the power of b plus 3 to the power of b plus a. So when we simplify this, we can put it in the bracket form of 4 to the power of 3 a plus b times 3 to the power of a plus b. Here we get 4 times 3. Of course, 48 is 4 times 12. 36 is 3 times 12. So we got the 212 here. If we multiply 3 by 12, 3 by 4, we get 12. So we got 12 times 12 times 12. Here we have a plus b times 3 to the power of a plus b. So we can take the power as a common for the 2. So we can multiply 4 by 3 to get 12 into this. So we got 12 to the power of a plus b, which is equal to 12 to the power of 3. Because the bases are the same, we can say that the powers need to be the same. So a plus b should be equal to 3. So if that, we call this equation number 4. If we bring equation 3 into the game, so we can work out a is equal to b plus 1. So we can substitute this back into equation 4. So we can say b plus 1 plus b, which is this one. A is b plus 1, so b plus 1 plus b is equal to 3. So we get that b is going to be b is 1 here, because when we bring 1 here, 3 minus 1, this is 2b, so 3 minus 1 is 2, 2 over 2 is 1, so b is 1, and a is b plus 1, so 1 plus 1, so we get a is equal to 2. Let's check if this is right or not. In our first equation, 4 to the power of a, 3 to the power of b is equal to 48, 4 to the power of a. So we put our numbers, a is 2, b is 1, so we have 4 to the power of 2.
So high I'm hypnotized. What's up is down, what's left is right. Chasing stars and holding you. I can't see the end, but we'll see it through.